Alright, we had a few word problems that we had to try solving quadratics, and here is problem number 1. We have a rectangular field enclosed by 400 meters of fence. So here's a rectangular field. I know in my given statement that I've got 400 meters of fence to cover or to surround that field, and I want to find the max area and the dimensions that will give that maximum area. Oops. So it's pretty straightforward. And right away when I see a problem like that, I pull out the L and W for length and width, because that's one of the quantities that we measure and look at rectangles with. And I know that if I add up all the sides, I can only use 400 meters of fence. So this is a true statement. That if I added up the fence on L and W and W, it would add up to 400 meters of fence. That's how much I get to use. Okay, and then I can also write how I calculate area, which is length times width. Now, those two equations, there's actually three variables in this problem. There's L, W, and area. But area is kind of a highlighted variable because that's what we want to maximize. And we want to get that area in terms of length or in terms of width. So what we do, and we looked at this in class, is I would take this equation and I would solve it for either L or W. I'm going to solve mine for L, but it doesn't matter. I divide by 2 here. That's what L is equal to. And I'm going to take that and substitute it in for L in the area equation. And that would yield the following result as I substitute in. Area equals, here comes that substitution, L is now 200 minus W times W. So this equation I can simplify just a little bit. I'm going to distribute that W in order, or rearrange my terms. W times W is W squared, but it's going to be negative, plus 200W. So at this point, I know a function or an equation that tells me the area in terms of the width. Okay? By in terms of, we just mean the area can be calculated with just knowing what W is. So I'm going to work with that now. Let's erase a little bit of our stuff up here. I'm going to work with that equation. I know that if I were to graph that area function or area equation, I would get a parabola because it's quadratic. Remember, quadratic means x squared, in this case W squared. If I were to graph it, it would be a parabola that opens upside down. And on the x-axis would be the width, and on the y-axis would be the area, because A is acting like the y. And what I'm looking for is where is that maximum, the highest or greatest area. And that happens to be the vertex of the parabola. So let's calculate the vertex. We know vertex is calculated with negative b over 2a. So this is my b value, 200. And it's going to be negative 200 over 2 times a, and a is negative 1. And I find out the width that gives me the maximum area. Remember, that's my axis of symmetry. It's going to help me find that point up there, that vertex. That's negative 200 divided by negative 2 is 100 meters. So if I make my width 100 meters, I will get a maximum area. Now I don't know what that area is, and that was part of the problem. But if I want to calculate the area, let's go ahead and first, I have this nice equation for area equals length times width. If I know that my width is 100, and I also know I only get 400 meters of fence, and I also know that these two L's are congruent, that means my rectangle actually has a better term for it. Turns out it has to be a square. And you can see as I walk around this rectangle, 100 plus 100 plus 100 plus 100 is 400. And therefore the area is going to be equal to length times width, 100 times 100. That'd be a 1 with 4 zeros. 10,000 square meters. And that is the maximum area. And that problem now is solved. I know my length, I know my width, that gives me the maximum area.